Hello my dears. So how you are? So today we are going to discuss about the last session we discussed about the circuit breaker, right? Circuit breaker. And now we are going to discuss about relays. Relays. So basically what is meant by relay? I already told you, I gave a brief idea about the relay. That is nothing but, my dear, it is the sensing element actually. So it senses the fault, it senses or detects the fault, and it tells the circuit breaker that circuit breaker, now you can trip. Okay, that message will send to the circuit breaker. So that is the simple definition of a relay. So relay, in other words, we can say that it's an electromechanical switch. In other definition, you can give like it's an electromechanical switch. That means so the relay is always a relay plus a circuit breaker combination will be there. Okay. So the relay will sense and it will send a signal to the circuit breaker so that the circuit breaker will trip. So overall, the relay can be considered as the what media? It is like a electromechanical switch. So now we are going to discuss about the basic principle of operation of a relay. So for that I am going to recollect our basic diagram that is already discussed. What was the diagram? My dears? Already you have, right? I will draw once again. Okay, just a brief, to get a small idea, right? We will use the same diagram so that we will get the knowledge of what is actually happening in the relay. Okay, for that I am using this diagram. I think this was our diagram, right? So this is the circuit breaker and these are the fixed contact, my dears, and there will be a source also, right? Source also, and this will be the what? CT secondary or relay coil. Both are same. This is nothing but our load. This is CT primary, you know that, no need to explain. So for the working of or the how a relay is operating, I'm going to discuss the same diagram, refer the same diagram, my dears. So in the diagram you can see that, I think it's clear, right? It's visible, right? The diagram is visible, right? Yes. The diagram is visible, right? Yes. Yes. For the clear understanding of the relay, see, my dears, the operating torque or the operating force of F of a relay is given by, my dear, K1 into I square minus K2. This K1 is a constant and together this K1 into I square is called the deflecting torque or operating torque or operating force. Or this K2 is nothing but, my dear, restoring force. So I will tell you how this equation can be applied here and how we get the idea of what the function of a relay or simply what is the principle of a relay. See, my dear. So this is nothing but a normal operating region, the load is absorbing certain amount of current and this is in this position, right? This is in this position. To make this is in this position, there will be an attached or there will be a spring attached which is to this circuit breaker so that it will be always like this. Is it clear? Under normal operating condition, my dear, this will be the what? This will be the structure. That means the fixed, this is a moving contact, right? This is MC. This is attached to the fixed contact. This is the fixed contact and this is the moving contact. And this MC is attached to the fixed coil. under normal operating condition. That means for fixing this to the fixed coil, moving coil to the fixed coil, what happened? There should be a torque or force, simply a force. That force is actually provided by spring. That force is actually provided by what, my dear? A spring. So the force which is required to hold this moving coil into this fixed coil is called the restoring torque. Is it clear, my dears? So in this case, or in this simple relay, the restoring force is provided by spring. So we can say that in this, from this diagram, this restoring force is provided by spring. Provided by spring. Okay, is it clear? So when an abnormal current is flowing in through this circuit or towards the load session, what happened? The current here increases proportionally by the transformation ratio of CT. There will be an increase in current also. This plunger is about to set a specified value of current, that such that if this value of current is exceeding the set value, that means the secondary value, the secondary current, my dear, this is at BIS. The secondary current of the CT is exceeding the set value. What happened? The plunger will pull towards downward. The plunger will pull towards downward means they are acting a force called the operating force. Due to this K1 into I square force, my dears, this plunger is actually pulling down. The force existing between this is a of course there will be magnetic field when alternating current is passing, you know that. So what happened means, due to this alternating current there will be a magnetic field. That magnetic field attacked the plunger. Plunger is nothing but an iron rod. Magnet always attract an iron rod, right? So it will attract the iron rod and there the plunger will close this circuit. That means that K1 into I square is provided with the CT secondary, that's all. The K1 into I square is provided by CT secondary. Is it clear? So what happened if the force produced by this secondary of the coil, that is a relay coil, then the force already the moving coil attached to the spring. Now this force is greater than the attractive force of this MC to the FC. What happened? If this force is higher than this force, the arrangement is set in such a manner that this will close the circuit and this MC will be moved towards the coil due to the force experienced by this coil. This is also a plunger, this is also a plunger, both are what magnet? Both are electrical material, that is nothing but iron rod. If the force exerted by this will be greater than the force already in between the spring of this MC and FC, what happened? The MC will move away from the FC and finally the circuit will break. So that is nothing but, my dear, I will say again, for operating, like I will say like this, for the operation of the relay, I can say that operating force greater than restoring force. That means nothing but, my dear, K1 into I square greater than K2. Or I can say that I square greater than K2 by K1, simply I2 greater than root of K2 by K1. This I2 is nothing but, or the simply root of K2 by K1 is called the setting of relay, or simply current setting. Current setting of relay. It is called what, my dears? Current setting of the relay, or in other words, pickup current. Or in other words, pickup current. Use this directly, not this one. You can directly use the word pickup current. It's good. So this is called the pickup current. What is this? Pickup current. Is it clear? So, different types of relays are there. This is just a simple example so that we can give only two forces and we can derive some relation, and what is the meaning of reached where, what is the meaning of pickup current? It is root of K2 by K1, that's all. For examination point of view, my dear, this is for our understanding purpose. The examiner will not ask this K2 by K1 or anything, it will not ask. The problems associated with the relay will be normally asked. Plug setting, multiplier, and some types of relay and what are the uses, that's all. But for our satisfaction, I am telling all this. And if you search Google or if you search YouTube, so many relays are there, my dears, and each relay having the operating principle basically may be same, but the forces, the torque equations, and here only two coils are there, but in some relays they may use 4 coils. Clear? So many different phases of relay you can see there. Okay, but the basic principle of operation is similar. That means there will be two forces, my dear. If one force is greater than the other force, the relay will operate. If this force is greater than this force, the relay will not operate, that's all. So basically this is the principle of a relay. Okay, from next class onward, we will discuss about different types of relays, my dear, different types of relay. Thank you.